And the project is the vAirify project. And the goal is to help improve the air pollution forecast model to be more responsive. And Miha is one of the mentors and said that he would introduce the team and the project.
Gladly.
Thank you.
Yep, so another CAMS-related project. So we talked already a little bit about the verification. We produce a lot of data sets and a lot of very kind of prominent data sets as well. And one of the probably most visible or most kind of used are the air quality forecasts for CNN. So we provide air quality forecasts that are used in CNN air quality bulletins. And we do a lot of internal validation. We use official data sets from Europe, from North America, from Japan. But the problem is that we are trying to do global forecast. And a lot of areas in the world don't have a good official observation networks, or at least not easily accessible. So there are kind of these citizen science or unofficial air quality observation networks, and we really wanted to see what is the potential of this data set. Is there something that we should be using, and how should we use this data in our kind of day-to-day work? So by some crazy stroke of luck, this team answered our challenge, and I'll give the floor to them to present what they've done.
Okay, yeah, thanks, Miha. So we're lucky to have quite a big team. We're mostly from a consultancy called ScotLogic, but we're also joined by Seb here from the University of Bristol, who's a climate scientist. So that was we're quite a good combined team. And we're supported by Mark, Miha, and Johannes. So first of all, we'd like to talk a bit more about our goal. So our goal was simply to develop an online dashboard for displaying and monitoring air quality forecasts for cities around the world. That's sort of the headline. And an example forecast is shown on the left here. Sorry, technical issues. Right, hang on.
We are sharing via Zoom.
No. Do you have the clicker to change the slides?
It's fine, yeah. So I've got I'm just not showing the slides correctly. So
No, we are sharing via Zoom the presentation for the demo.
yeah, I will get there. Entire screen.
Didn't switch to Zoom. Their slide they're showing.
Okay. Oh, okay. So, right. Okay.
Should be fine.
Right. Okay. Yep. Thanks, Seb. So yes, the picture on the left is an example air quality forecast. This is something that CNN show on their TV broadcasts around the world. And it's just a forecast, so sometimes it's not right. And there's an example on the right here of New York. So on the 7th of June last year, the forecast for the air quality was good, but in fact, the air quality was really bad. At the time, there were various sensor networks doing lots of long-term evaluation, lots of data being gathered, but there wasn't a quick and easy way to see what the current conditions were like. And unfortunately, the first time that the forecasters knew of the issue was via the press. So there's a need for an online dashboard that gives you a nice, quick and easy idea of what's happening at the moment. In order to provide data for this dashboard, we need to get that information from sensors. There's two different types. There are official, highly calibrated sensors and low-cost sensors. The official sensors look a bit like this, and they're clustered in around 3 main networks, and these are centered on Europe, US, and China. And you can see for where they're centered, the coverage is really good. For the rest of the world, it's not so good. There's only a few sensors in Africa and none in South America. The data from these networks is then put into these long-term evaluations of forecasts. Then we've got low-cost sensors that look like this, and these feed into open networks like OpenAQ, together with the official sensors. So this is all the data all in one place. And now we can see that we've got better coverage. Still not amazing, but it's better. We've got a load of sensors in here for South America. But we don't really know how good this data is from these low-cost sensors. Is it reliable and accurate enough to use for improving forecasts? So for that, I'd like to hand over to Seb to talk about the data.
Thank you, Tim. We wanted to start with a brief introduction or overview what kind of data we actually are dealing with, because we spent a lot of time initially during the project working to better understand and to screen the incoming data from the OpenAQ platform. To illustrate this, I just show you this map here, showing like a typical request that we do for our 153 target cities around the world.
Clicker doesn't work.
No, it's okay.
He's just pointing.
Okay, sorry. So with a 25-kilometer search radius around the city center for a list of 5 pollutants, so particulate matter, 2.5, 10, ozone, and NO2 and SO2, and for time range in this example for just 1 week. And this map shows you the result that we get. Basically, there are 600,000 individual measurements returned. We already cover with this one data source, so OpenAQ platform, roughly 100 of these 153 cities here, shown as these black dots distributed across 1,300 stations globally. But if you just take a closer look at the data that we get back, was quite some work to do with that. So just showing 2 examples, time series of Vienna, 7 days data for ozone, and for Jakarta, PM2.5. Different colors here, meaning different measuring stations that vary well over the time. And you can already see these time series look quite different. So we sometimes have gaps in the data. We sometimes have very large negative values. So it turned out that some missing values are encoded differently in different data sets in different countries. So cleaning this and converting units and all these things was a large part of our initial work. But this is only the first step of our software platform, and how we, after ingesting this data into a software, to give you an overview about the rest of the architecture, I hand over back to Tim.
Okay, so the architecture of vAirify looks like this. At the bottom, we've got 2 components to extract that data from these 2 sources. Those then transform the data so that it can be compared and load it into a database. At the top, we've got the user interface itself, which accesses that data via a published API. And on the left, we've got a store of bitmap images that we can use for creating maps later on. One thing I want to talk about before Max shows you the actual product, and that's something important, the color scheme. So there are a number of different color schemes for AQI levels. We've chosen the European Environment Agency scheme, and this grid basically gives you different levels for the different pollutants, from good in blue through to extremely poor in purple. At the top, there's the top-level expression of the air quality, the AQI itself, a simple number from 1 to 6. So now to Max to show the product.
Thank you, Tim. So we've been brave enough to actually give you guys a live deployed demo. Alt-tab. So here is the landing page that you'll get onto when you visit the link. So at the very top here, we've got the forecast base date. So I appreciate you can't see it too clearly with the... So yeah, the forecast base date, that window it will basically allow you to, I guess, select where you want to have your forecast starting from. So for each forecast base date, we get CAM's forecast data for 5 days maximum. So from here, I'll also be able to filter those forecast days if I only want to see just a few of those days. And then you'll also be able to kind of see the actual filter that's been applied here with the time range. So for particularly here, we've got the 1st of September, midnight. And so we have 5 days from there, but we've only kind of chosen forecast day 1. So we'll only see the data from that 24-hour time window. So if you then look at the actual grid here, we've got our cities towards the left here, and then we've got all our pollutants and our AQI level on the right. So what's happening here is we've got the cities, they are basically sorted based on which city had the highest discrepancy between the forecast and the measured. And as you can see here, in each individual pollutant, we've got the forecast and the measured as a subcolumn. So for example here, if you look at PM10, we had a forecast of 200.7, which is AQI 6, and then 18.3, which is AQI 1, on this particular valid time here. So since this was the biggest discrepancy within this time range for Dubai specifically, then we display that as the overall AQI level here. And yeah, you can also see the diff here. It's basically saying that we over forecasted by 5, pretty much. And we've obviously got the colors here, but if you're just interested in what kind of pollutant is causing the highest discrepancies, you can just toggle those off just to see the ones, I guess, you're most interested in. Now, if we go into an individual city, if we go into Hong Kong, you can now have a more kind of visual sense of what's going on with the in-situ sensors that are dotted around the actual location. So we've got kind of the same thing, but just as visual graphs. So you've got our overall AQI graph here, of which the black dotted line is our forecast, which is given every 3 hours, and the blue line is our in-situ line, which is given every hour. So this in-situ line is basically showing you the real-time value as opposed to what was forecasted. And this is actually is dynamic. So each of the kind of colored lines on our individual pollutant graphs, they represent a site. So if I kind of deselect this site here, you'll see the blue in-situ line change and shift. This is useful if you've got anomalies and you want to get rid of them. So yeah, that data changes. And you can also obviously add them back in via the drop down here. And we also have a nice map here where you can actually see where each of these kind of sensors are around the map. And you can also do the same thing in here by being able to add and remove sites back in here. And also the charts can be exported as PNGs for, I guess, any blogging or any kind of thing you want to show online. And that's it for the demo. I will now pass over to Mike to show the testing section. Uh-oh. Mike.
Thanks. Hi. So we knew that vAirify was going to be developed using an agile approach. So by that, we split the work into small pieces of functionality based around the requirements that we got from the mentors. We then tracked this work using a Kanban board. You can see an example of one behind me here. It's quite a simplistic one, but it's a way of making sure that we try and get as soon as possible something small working that's tested, and then to get feedback from the mentors and to iterate upon that and build. An output of our testing strategy was that any work on a feature that needed to always work, or things that should never happen, would be encapsulated in test cases. We aim to automate these where possible, and we put them into what's called a regression suite. Regression suites are something that you would run against any new feature that comes in to make sure that you haven't broken something pre-existing by the new work. All other testing was done via exploratory testing. So I've got a picture of a book here which kind of guided some of this, Explore It by Elizabeth Hendrickson. We use test charters as a way to do session-based testing, and it's a great way to find deeper bugs in your software. Okay, so regression testing in the back end was written in Python. We used PyTest as the test framework. This is an example here of a well, it's a PyTest test. It's hitting the forecast endpoint of our API. So this API retrieves forecast data, funnily. And the point of this test is it's asserting that when it's provided with the correct parameters, you get a 200 response indicating that it's been successful back from the system. And what we're doing here, we're using PyTest's parameterization feature to send 2 different payloads in, which represent the API parameters. The top one is different because it's got an extra parameter location name, which is optional. We have tests in the back end which test the API and also all the different parts of the ETL process as integration tests using mocking, and also we seeded data in a QA database. In the front end, the automation was written in TypeScript, and we used the Playwright framework for the automation. It's really powerful. If you haven't used it, I recommend it. We structured the tests using a page object model, which is a brilliant way to separate test code from implementation details. It makes more maintainable tests, and it makes them easier to read when you're looking at them. The actual test that we were doing in the front end, we were mocking, so we would be sending mock data to the summary table on the front page and asserting on the structure of the table that's represented or the color scheme. On the city page, this is an example of snapshot testing that you can do in Playwright. So we'd have tests that would assert that the graph would be represented in a specific way, and if it was no longer presented in that way, when the test takes a screenshot, you get this nice diff representation of what's changed. And I just wanted to finish by talking about regression testing in action, so where we caught a problem using this methodology. We introduced a story, this top one here. As a user, I want to be able to choose the forecast window. And immediately when we ran the tests against it, one of the tests broke. And the test that broke asserted that when you set the date to more than 5 days in the past, you'd get 41 API calls made to a particular endpoint. We got 72, and digging into it, we established that it was not just requesting data for 5 days, it was requesting data up to present. And then when you went into the UI, because as testers we do this kind of thing, and set the date to the year 1900, it tried to make 400,000 requests for over 100 years worth of data and took our application down. But our automation basically caught the problem immediately, and we could fix it. I'll hand over to Seb now.
Thanks, Mike. Can we go back to the presentation? So the vAirify dashboard is live now, but it has been an open source project right from the start. So we don't see the current version that is online now as sort of like the end of the road, but hopefully rather as a start of a new platform to really merge the CAM's air quality data and the real-time measurements, and to enable new applications for the future. And I just wanted to briefly mention 2 possibilities that we are already working on. First of all, we decided to make the backend and the API to access our backend publicly available. So this is currently used to run the dashboard, but everybody can access the backend to use the data that we gather and we cleaned basically for their own analysis. And for this, we provide a Jupyter notebook within the repo, for example, to explain how to use this API to get also not only like 1 or 5 days of data, but maybe like a month or 3 months of data for an individual city. So it's very easy to use and explained in this Jupyter notebook. And the output looks like something like this. And people can just use this data then for in-depth analysis or statistical analysis, however they like. And also there's a new experimental feature also on the dashboard now, where we actually go 1 step back and show a global map of the forecast data to make this data even more accessible to a wider audience. And I just want to briefly show you this as well. So this is the dashboard that Max already showed. There's a button at the bottom to actually show the same data in a map view, which is shown here at the bottom. I don't know how much frames come through Zoom here, but should be fine. So basically, this is as we imagine it, as one step back of the table view at the top, which is great for the expert user, for our mentors, first place. But we think more people can benefit from our work, hopefully, in the future. And therefore, we started with this map view now to, first of all, to show the global forecast data as a background overlay, all of the locations that we actually acquired as real-time data for compared with the data with our forecast data, and then the user can start, like it was in the challenge description, to play and explore basically the underlying data. So this will update based on the selected forecast base date and forecast length. Let's say like goes to something more recent example maybe. And then the user get this timeline at the bottom to really, to just explore, to see how this changed over this forecast length, how the in-situ data updates, where are the hotspots, where are differences, what does the model do. You can then always go into more detail by just zooming into a certain location. For example, seeing the forest fires there over South America for the recent days, how this relates to worse air quality in the affected regions, and then you can really start to see what kind of locations we actually have available that might pick up the signal, how does it compare to the forecast data, and we also added functionality to just look at the same data in this globe view to just be able to just explore the data, look into specific regions, to, for example, then also look at the actual grid point information that is in the data. So you can always look at what is actually stored in the actual model resolution there. Look at different variables, for example, to just see how the different pollutants make up the overall air quality index, how this changes over time. And I think there's just a lot to actually just explore for exploration for the user as a first start, and hopefully this might even be transferable to other CDS, ADS data sources in the future. So,
what's the size of the circle?
Pardon?
The sizes of the...
Oh, sorry. The sizes of the circle. Just go back to the world map view. They are, at the moment, they are just scaled by the overall AQI difference, or even in this case, the pollutant difference between the in-situ mean and the forecast at that location. So basically, they represent the first row, the diff row in this table. So the data always represents the same data as in the table, but we see it as sort of like a temporal and spatial expansion of the table in a way to explore this. And it's, at the moment, it's just scaled to just guide the eye sort of like to the hotspots. Like if you look at this, like you will always see, okay, there's something wrong with Lima, or some locations really where we overestimate the in-situ data quite a lot. So as a first guide for your eyes, basically. That's the idea, but you can configure that. Okay. So this was just like two of the, what we think, quite exciting possibilities, what we can already do with the current platform and might be able to do in the future as well. And I will hand back now to Tim for some concluding remarks.
Okay. Thank you. So yes, in conclusion, I think we can say that we've met our goal. We've got this dashboard available now for forecasters to use, and it's being used pretty much every day to help spot those differences. This is using a lot of data from these low-cost sensors via OpenAQ. And we've got some examples here. The first one for Los Angeles. This is an example of spotting things as they happen. So we were looking at the tool on the 5th of July, and we saw these big peaks across many US cities. And what's going on here? And it was the Independence Day fireworks. Really clear signal in the data. And the one on the right, that's something from Mark Parrington, and another one of our mentors, where he was looking at long-range smoke transport across the Atlantic from the wildfires in Canada. And he saw that a peak of data in the official networks was also being reflected in our tool. So that kind of shows that this open data from these low-cost sensors is going to be useful for longer-term analysis. So I just wanted to finish with a picture of us in action. So yes, it's a slightly staged photo, so some of us striking poses. But it's a real meeting, honestly, talking about process. There's a link there to the product if you want to have a look yourself, and there's documentation in GitHub to describe how we've done this. And yeah, lastly, thank you to the ECMWF staff, Code for Earth team, and especially our mentors. This is not something that Scott Logic normally does, so we've really enjoyed the opportunity to contribute in a small way maybe for reducing the impact of air quality worldwide. So thank you very much.
Yeah, thank you very much, Tim, Seb, Max, Luke. Nice presentation. Are there any questions? Is all crystal clear?
Very nice job. Very nice.
Thank you.
Let me check if there are any questions. There is a question.
It's not really a question, just I think that you should connect to a laboratory in Aristotle University of Thessaloniki that are doing the same thing with DIY sensors, and you could benefit from a meeting. Perhaps you can do stuff together. Just
Okay, yeah, if you could put us in touch.
Yeah, so we still have the evening reception. So and essentially the day-to-day is to connect each other. We don't have any questions online. So thanks again for your contribution, for the presentation. That looks very dynamic. Good, another round of applause to the team. Thank you very much.